Hi, we are Ovia Soundarajan, Blaine Garber, and Caitlin McGrinder. For our chemistry concoctions project, we tested the temperature of the center flask in the lab. The research question we developed and tested was, does an increase in the temperature of the water in the center flask change the volume of water that ends up in the graduated cylinder? We later developed a hypothesis surrounding that research question as well. The one and only independent variable was the temperature of water in the flask. However, in this lab, there were several controlled variables. Some of the controlled variables were the size of the middle flask, which was 250 milliliters, the amount of water in the flask, which was 200 milliliters, the 6 milliliters of acetic acid, and our choice to use vinegar as the acetic acid.
In our experiment, we also controlled the amount of baking soda or sodium bicarbonate at 0.2 grams for each trial. After combining the sodium bicarbonate and acetic acid, we swirled the container in a circular motion to allow for equal distribution of the two chemicals. We had one dependent variable in our experiment. Our dependent variable was the volume in milliliters of water that would be transferred over to the graduated cylinder after the trial was performed. We believed that the change in volume would change depending on the temperature of the water in the middle flask. Once we combined the sodium bicarbonate and acetic acid and plugged the flask, the water from the middle flask will transfer into the graduated cylinder. My group and I tested the idea of changing the independent variable of the temperature of the middle flask to see if it would affect the volume transferred to the graduated cylinder. Therefore, our group's hypothesis was that if the temperature of the water in the flask increases, then the water in the graduated cylinder will increase. We believe that this would create a direct relationship between the volume and the temperature.
We formed our hypothesis based on the knowledge that temperature increases the speed of particles, so therefore the particles in the water would be moving faster, which would both help them move into the graduated cylinder and also eventually expand the volume of water. So we collected data to support our hypothesis and eventually either prove it right or wrong, which in the end we did prove to be right. You can see in our data that we did 5 different levels and 3 trials each. And from each level, we increased the temperature 10 degrees, and we saw that on average, the volume of water increased. There was a point where from 30 to 40 where the increase was smaller than the rest, but that may be due to issues with the experiment, such as the plug cap and the heat changing, since it was difficult to move the heat directly from the hot plate into the middle flask. But you can see everywhere else it's consistently moving about 10 degrees, 28 to 38, 42 to 54, 54 to 63. You can also see this in the graph we made, and you see a very steady line and a direct relationship on the graph. There is just those 2 points where it's stagnant from 30 degrees to 40 degrees. So based on this information, we could conclude that our hypothesis was most likely true. The average from the beginning temperature to the ending temperature increased from 28.66 milliliters to 63.33 milliliters, suggesting the temperature of the water in the middle flask directly affects the amount of water that transfers in the graduated cylinder. Aside from the points 40 to 50 or 30 to 40 where we saw a slight increase, overall there was a pretty accurate or pretty relatively precise increase from each level. So in conclusion, as the temperature increased, so did the volume in the graduated cylinder.